Hi guys, welcome. This is Math 6 Day 22. Today we're looking at lesson 57 and 58. So lesson 57, adding and subtracting fractions. We've talked about that. And we have to rename or change the shape, perform the operation indicated, and then simplify. It'll be these same steps when we get into multiplying and dividing fractions down the road. The nice thing about multiplying and dividing is we don't need common denominators. For adding and subtracting, we do. So 1/2 plus 2/3, we need to make this again common denominators. So 2, 4, 6, 3, 6, 9. Sometimes it works out, you can just multiply the two denominators together and that ends up being your least common denominator, but not always. I know we will watch a video that talks about that. That's one way to do it, but then you may have to reduce more in the end. So I don't love just jumping straight to that because sometimes it's more work. Okay, so we get common denominators. So now we can add 3 plus 4 is 7, 6. This is an improper fraction, so 6 goes into 7 once with 1 left over. So 1 and 1/6 if we want to put it back as a mixed number. Okay, for subtracting, again, we need common denominators. So again, this is where I said I don't love the method of, because 3 times 6 is 18, but that's not the least common denominator. We have 6, 12, 18, but then 3, 6. Oh, so this one we just need to change. So 5, 6 we can actually leave alone, and then this can become 2, 6. We do 5 minus 2 is 3 over 6, but we need to reduce. 3 goes into both of these, so and 3 over 6 can reduce down to 1/2, because 3 goes into 3 once and into 6 2 times. Okay, practice set, we'll do these together. We need common denominators, and then we need to reduce or simplify. That's really the only difference from this to what we did in a previous lesson. Lesson 58 deals with probability and chance. So probability, you've probably heard, what are the chances of rain tomorrow? What's the likelihood of this happening? Your favorite team to win the Super Bowl, what are the odds? Okay, those all work hand in hand, and that's what's known as probability. So probability helps us assign a number to uncertain events and compare the likelihood that various events will occur. Now, it always is between 0 and 1. So if we're talking about percent, 0 and 100%. If we're talking about fractions or decimals, 0 to 1. So if it's right in the middle, there's a 50% chance or a 1 in 2 chance of it happening, then it's even. It's not more likely or less likely. If it's getting closer to 0, it's less likely. Like, what's the chances of winning the lottery? It's like 1 in several billion. Not a very good chance. Still out there, but it's like 0.000000001 or something like that. It's very, very small. Okay, the likelihood of something happening, if it's almost certain, then it's 1. What are the chances of you passing the test? Well, hopefully it's a 1, but let's say it's a 0.9 or 0.95 or something. So it's always between 0 and 1. Never negative numbers, never greater than 1, because again, even if it's, what are the chances it either rains or doesn't rain tomorrow? Well, it's got to rain or not rain, so that's a 1. There's a 100% chance of one of those happening. So it always is between 0 and 1. Our sample space, that's a new term, that's all of our possible outcomes. So it can be written like this. If we're flipping a coin, spinning a spinner, we have to pay attention to the likelihood of them happening, though. So if we're looking at this spinner A, B, or C, well, clearly A has a better chance than B or C because it takes up half the circle, whereas B and C are only 1/4 of the circle. Okay, so we have 1/2 plus 1/4 plus 1/4 equals 1, or 0.5 plus 0.25 plus 0.25 equals 1. And we're going to land on A, B, or C. It has to land somewhere, but there's a greater probability of it landing on A than B or C. So Meredith spins that spinner we were just looking at. About how many times can she expect the spinner to land in sector A if she spins it 28 times, in sector B and C? Now there's theoretical and experimental probability, and we'll talk about those differences down the road. For now, we're just looking at theoretical, just mathematically. It's like flipping a coin, heads, then tails, heads, then tails, heads, then tails. But we know that's not always going to work out. It may be 7 heads in a row. We don't know. Okay, so if we have 28 times, okay, half of the sector is A, so there's a 1 in 2 chance, or 0.5, so we can do 28 times 0.5, or 28 divided by 2. That gives us 14 times. 0.25 times 28, or 1/4 times 28, would be 7. Okay, so that would be, for B and C, they'd be likely to land there 7 times, and 7 times, and then in sector A, because that was half, well, we spin 28 times, we can expect that 14 would land in sector A. And again, experimentally, it may work out to be different numbers, but that's our theoretical probability. Okay, if we say weather forecaster says there's a 60% chance of rain, again, 60% chance, that's still a probability. It's either going to rain or it's not. 60% is greater than 50%, or half, so we say that there's a good chance of rain. If it said there's a 5% chance of rain, we probably wouldn't get our umbrellas and rain boots because that's not a very good chance. Okay, so 60% we can write as a fraction, 60 over 100, reduce it down to 3/5, or move the decimal 2 places to the left, which gives us 0.6. Okay, so again, between 0 and 1. The complement of event is the opposite of it. So if we're looking at rain, well, it's either going to rain or it's not going to rain. So not raining would be the complement of an event, and they always add up to 1. So if I say flipping a coin, we get heads or tails. Well, we have a 1 in 2 chance of getting heads, or we have a 1 in 2 chance of the complement of not getting heads, which is tails. 1/2 plus 1/2 equals 1, because it's got to land on heads or tails, or not heads. 1/2 plus 1/2 equals 1. So the probability of an event and its complement are always 1. Let's look at example 4 here. A bag contains 5 red, 4 yellow, 2 green marbles, and 1 orange. Without looking, Brendan draws a marble from the bag. So we have 5, 9, 11, 12. So 12 marbles. The probability of drawing red would be 5 in 12. The complement would be not red, which is yellow, green, or orange, which adds up to 7. So 7 in 12. 5 in 12 plus 7 in 12 add up to 1. The probability of the complement is 7 in 12, because if there's a 5 in 12 of drawing red, there's a 7 in 12 of not drawing red. Okay, and we'll look at some more examples in the practice set when we return. Just remember probability, it's got to be between 0 and 1. We can write it as a fraction, a decimal, or a percentage. Complements are the opposite of an event that we're talking about. So drawing a king out of a deck of cards, the complement would be not drawing a king. So everything else that's not a king would be the complement to that. Okay, we'll go over these and then proceed from there.